there are two types of extrinsic semiconductors. One is N-type and one is P-type semiconductors. Whenever there is a production of a cycle due to electromagnetic induction, mutual induction concept and all, whenever there is a current, whenever the source is set up, so there is a flow of current over here which will induce a current on this. Hello everyone, I'm Brinda, Faculty of Physics, welcoming you all to Chapter 14, Session 1, and chapter name is Semiconductor Electronics. In this chapter, we are going to deal with the last topic of your syllabus as well as your one of the important chapter wherein you will have to study much more about the metals, conductors, how it reacts and all those concepts, wherein you have p-n junction diode. Till there you have the syllabus. So now if your classification of the metals, conductors and semiconductors turns out to be metals. What is meant by metals? So as you all know, metals is the one which acts as a conductors, and you have one more concept called as a semiconductors. So even you have a concept called as insulators as well. So metal is the one which acts as a conductor, which means to say that there is a electricity passage. That means you have two bands called as conduction band and you have a band called as valence band, which is the least one. So every time the electrons from the valence band jumps to the conduction band on giving up certain energy to it. Whenever the energy is produced, the electrons from the valence band jumps to the conduction band, which gives you a process of conductor. That means there is generation of electric current. So whenever there is a jumping of the electrons, wherein in conduction band it is a holes which is placed. So whenever electron jumps and sits inside the hole, there is a formation of holes over here in valence band. So all the electrons which are in valence band jumps to the conduction band. That is actually the process which takes up in this chapter. Okay, but in case of your metals and the conductors, it is both the same. We have the energy gap between the valence band and conduction band is absent. The energy gap, this is called as a energy gap or a forbidden energy gap or a forbidden energy gap. This energy gap is nil in terms of metals or conductors. In case of semiconductors, the energy gap is said to be lesser than 3 electron volt, wherein in case of insulator, suppose if you consider an insulator component, then you have a valence band and you have a conduction band whose energy gap is greater than that of 3 electron volt, because of which there is no jumping of the electrons from a valence band to conduction band, because of which it is called as insulator. It doesn't conduct or it is not useful for generation of electricity. Wherein the semiconductors is the one that is less than 3 electron volt. It acts as an insulator at certain time and it acts as a conductors in certain time. That is why it is called as semiconductors. Half it acts as a conductors. Okay, so that is the semiconductors. So for mainly we deal with this concept called as semiconductors. So first of all, semiconductors are divided into two types, and that is intrinsic semiconductors and extrinsic semiconductors. So here you can see intrinsic semiconductors are the semiconductors which are known as pure form of semiconductor, for which there is no impurity which is added to it. It is just a pure form of a semiconductor. We can give an example of silicon, germanium. All these concepts are the intrinsic semiconductors. It comes under the intrinsic semiconductor as an example. Intrinsic semiconductors acts as insulators at temperature 0 Kelvin. It will act as an insulator. That is the one which you'll have to note it down. Next is, contrary to that, we have a concept called as extrinsic semiconductors, where there are two types of extrinsic semiconductors. One is N-type and one is P-type semiconductors. In this form, you have N-type semiconductors are the one which has got added impurities. There is a impurities which is added to this type of semiconductors, and that impurities are called as dopants. So adding a dopant to a semiconductor, that is intrinsic semiconductor, you write dopant plus intrinsic semiconductor gives you extrinsic semiconductor. So what dopant you add for intrinsic semiconductor, that matters. Suppose if you add pentavalent impurities to intrinsic semiconductors, it gives you N-type semiconductors, that is extrinsic. If you add trivalent impurities to intrinsic semiconductors, it gives you p-type semiconductors. That is all about your extrinsic semiconductors. So your pentavalent impurities can be your phosphorus as well as arsenic component are known as pentavalent. Trivalent impurities can be your aluminium as well as boron. These are the trivalent impurities which are added to the or doped to the intrinsic semiconductors to give you p-type semiconductors. So going on to the next one, we have p-n junction. So you know p-type as well as n-type semiconductors. By studying on it, that is on introducing those concepts, what happens in p-n junction, p-type semiconductors are the semiconductors which has vacant holes, more of the vacant holes in it, and n-type of semiconductors are the semiconductors which has more of the electrons, extra electrons is available for in order to fill. So majority charge carriers in p-type are holes, majority charge carriers in n-type are electrons. So with the help of these two concepts, we have a certain set that is p-n junction. So there is a p-type semiconductors which is aligned along with the n-type semiconductors which is connected to a battery. Okay, so this is called as a p-n junction, which creates a junction in between whenever there is a passage of the current. Okay, so this junction is called as, or this region is called as depletion region. So this is the depletion region is the main part where exactly the working, everything happens over here, where in p-type the majority charge carriers are holes and minority charge carriers are electrons. In n-type, majority charge carriers are electrons and minority charge carriers are holes. This is how the concept turns out to be. Next is a semiconductor diode. That is, in case of p-n junction diode, that is, if you just check forward bias, before that let us check what is meant by biasing. Biasing means connecting the source, battery source to a diode is called as biasing of a diode, or a component is called as a biasing. So there are two types. One is forward bias and another one is reverse bias. So what is a forward bias? First of all, going with forward bias, diode is connected to a battery in what ways? That is, p-type is connected to positive of the battery and n-type is connected to negative of the battery. Okay, that is how exactly a forward bias turns out to be. So how is exactly diode given? Diode is symbolized as where this is positive and this is negative notation. So positive of the diode connected to positive of the battery, negative of the diode connected to negative of the battery gives you forward bias condition. Again, if you just draw a diode and positive of the diode is connected to negative of the battery and negative of the diode is connected to positive of the battery gives you a reverse bias. So whenever you study this, you can just get to know during the forward bias, the depletion region, that is, the positive charges here goes towards the p-type, negative charges go towards the n-type, both also fuse together when there is a passage or the attraction, that is, a positive charge is attracted towards negative type, negative is attracted to positive type. The depletion region which you had studied over here, it concises due to the flow of charges or due to the push of the charges. When the depletion region concises, there is a easy jumping of the electrons as well as the holes on either way, which results in the current. So in case of forward bias, there is a production of the current. It conducts, it is called, it conducts during a forward bias. In case of reverse bias, it is opposite, that is, the charges get repelled, that is, the electrons which are over here, that repels here and repels by these electrons which is present here. The positive charges is repelled by that. That is, like charges repel each other, unlike charges attract each other. So due to the repulsion, what happens there? The depletion region width broadens, because of which there is no exchange of the charges, due to which we can say that reverse bias conduction doesn't take place. It doesn't hold good to conduct. Okay, but here it is used as a conductor. That is forward bias. It is very good in conducting concepts. So p-n junction diode under forward as well as reverse bias is all about this one. Now we are going on to applications of the junction diode as a rectifier. So what is a rectifier? Rectifier is the process or rectification. Rectifier is an instrument wherein rectification, it is the process wherein it is used to convert. That is, if you have a AC alternating current, it is used to convert the AC signals to pulsating DC. So this is what the rectification is all about. In order to have this rectification, we have a concept called as a rectifiers. So we have a half wave rectifier for which we use one diode. Only one diode is being used. So we have a transformer which is given over here, which is later connected to a diode. There is a load resistor, call it as RL. So this is the setup of a half wave rectifier, wherein the input signals are measured in terms of A and B points. Here input signals are measured, here you measure the output signals. So you know about the forward bias and reverse bias. So there is a AC which is connected over here. Okay, so now whenever there is a production of a cycle due to electromagnetic induction, mutual induction concept and all, whenever there is a current, whenever the source is set up, so there is a flow of current over here which will induce a current on this. So if suppose you call this as a positive half cycle and negative cycle, so whenever there is a positive half cycle, it just flows towards the other way, and then you have a positive given to the p type, positive, and negative. Here p type it is given, negative is given. So whenever there is positive given to p type and negative signals given to the negative of the diode, then it is said to be a forward bias. When it is forward bias, it conducts electric current. So that is given in terms of the waveform. So you have a waveform, set of waveform. One is for input signals, another one is for output signal with respect to certain amount of time. And now you have half cycles are given in terms of this dotted lines, which gives you the rectification, how exactly it happens. So you know input signals are one first half, second half, first half, second half, like this. First half of the cycle is positive, second half of the cycle is negative. That is how it shifts. So for the first half cycle, there is a conduction which is taking place. So the output it conducts. So you have a pulsating DC over here. Okay. So the second half cycle, again, this turns out to be negative. Then this turns out to be positive. At that time, what happens? There is a production of negative. The negative is connected to negative of the diode. So what happens? You have a negative half cycle. Whenever a negative signal has been dropped to positive of the battery, that is called as a reverse biasing. Whenever reverse bias happens, there is no conduction. So you don't have any conduction or any output which is given over there. Then again, for the positive half cycle, you have a conduction. Again, for a negative half cycle, you don't have a conduction. So this is all about your half wave rectifier. Only half of the wave is rectified with respect to the cycles over here. Similarly, in case of full wave rectification or rectifiers, you have two diodes which is connected to a transformer over here. There is a transformer to which AC signals are connected. Here you will calculate output voltage wherein the load resistance has been placed, and input voltage is calculated over here. And this is diode 1 as well as diode 2. Similarly, the same component, whenever one cycle positive and negative we have, whenever it is positive, first time there is a input as well as the output voltage given in the waveform, and these dotted lines represents the cycles of the waveform. And now suppose you guess there is a positive half cycle which is flowing and towards D1, and negative half cycle is flowing towards D2. When that's the case, because of the first positive half cycle, the diode D1 forward is said to be forward bias and D2 is said to be reverse bias. So we have in this case, the cycles turn out to be in this form. So this is due to D1. The positive half cycle is due to D1. At that time, there is a conduction of current. Yes. So there is conduction. So you can show this is input voltage and this is the output voltage. And due to the another half cycle, that is the negative half cycle, what happens? D2 will conduct and D1 will be reverse bias. That will be reverse, this will be forward. So there is again conduction. So you can represent conduction. This is conduction due to D1. This is conduction due to D2. Again, next half of the cycle, again it will switch up and D1 will be forward bias, D2 will be reverse bias. Again, there is a conduction due to D1. So the conduction due to two diodes, either of the one will conduct at one cycle. Okay, so that concept is called as a full wave rectifier. The full wave is rectification is being done there. Okay, so this is all about your half wave rectifier and full wave rectifier concept. So first of all, you'll have to know the circuit diagrams along with that waveform diagrams. These hold good, or these hold as a important concept from this chapter. So in today's class, we have dealt with the semiconductor diode. What is P-type? What is N-type? What is intrinsic semiconductor? What is it? Extrinsic semiconductors, and how exactly it follows up, along with full wave rectifications as well as half wave rectifications. That's all about the semiconductor chapter. Let us all meet in our next upcoming session. Until then, have a good day. Thank you.